So in case of angular momentum, suppose there is a nucleus in the atom N, and in this nucleus at distance r there is an electron. Electrons which revolve around the atom with a velocity v. V is the velocity. Okay, v is the velocity. If mass of this electron, if mass, m is the mass of electron, then p is equal to mass into velocity is linear momentum. Linear momentum. So from the vector, the r cross x, angular momentum L is defined as, angular momentum L is defined as r cross p. R cross p. So the direction of cross vector is perpendicular. So this will be the direction of L. This will be the direction of L. R cross p. It is from the left hand side. This is your R. This is R, and here it is P. Direction is P. Then the thumbs is upper perpendicular direction. And this can be represented as R. What is R? Xi yj plus zk is the R, and this is pxi pyj and pzk be the linear momentum. And here it is Lxi plus Lyj plus Lzk be the angular momentum. So this can be expressed as I, J, K, X, Y, J, and here it is Px, Py, and Pz. This can be expressed as I hai, this is a row and this column is eliminated. So Ypz minus Zpy plus J को कर दें तो this is Zpx minus Xpz, and if we take the coefficient of K, then it is Xpy minus Ypx. This one is the component, and here it is Lxi plus Lyj plus Lzk. So if we compare the coefficients I with respect to I, then Lx is equal to Ypz minus Jpy, and Ly, this is the J coefficient, Ly is of this Z. So this is Zpx minus Xpz, and here it is K coefficient, then Lz. So Lz is equal to Xpy minus Ypx. Yeah. और quantum mechanics में, you know, the Px is the linear momentum operator is I H cross del of del x, and Py is equal to minus I H cross del by del y, and Pz is minus I H cross del of del z. This one is. So we take the commutation relation take the commutation relation of the angular of the components of angular momentum as Lx Ly, Lx Ly, then this is expressed as minus I H cross, then y del of del z minus z del of del y Lx and Ly is minus I H cross, and here it is Ly z del of del x minus x del of del z, del of del z. So what we find, this is I H cross with minus plus I square, that is something like minus I, so minus plus I square H cross square, that is minus H cross square. So this is minus H cross square, and this is y del of del z. This part is considered with this factor. So this is z del of del x minus x del of del z. Then minus of this z del of del y of this full factor z del of del x minus x del of del z, this factor. So this is minus h cross square, and here it is y into del by del z, del by z, del z. So here it is z and d of dx, but they two variables. So this is y dz by dz into dx, and then minus yz minus yz. हाँ
सर,
हाँ,
ये जो नितिन मैडम वाला था, प्रियंका मैम से बात हुई, उन्होंने कहा कि देखा तो
हाँ,
उन्होंने कहा कि इसमें काफी क्वेश्चंस आउट ऑफ सिलेबस हैं, इसको हम नहीं कर सकते, जो पढ़ाता है वही करेक्ट कर सकता
ठीक
है।
ठीक, हम आ रहे हैं, देख रहे हैं अभी क्लास में। y del z by del a del, and this is del square del z square, then minus of z, this is z, and then Ly. So this is Z square, Z into Z square, and del square del Y del X minus ZX del square del Y del Z. This minus minus here it is plus as well. So this factor is minus H cross square, and del Z by del Z is 1. So Y into del X minus Y del Z del Z square minus Z square del Y del X plus ZX del square del Y del Z. This one is. This is LX Ly. Similarly, Ly Lz Lx. This is Ly Lx is, this is minus IH cross Ly. Ly is this much, Z del of del X minus X del of del Z into minus IH cross Lx Y del of del Y Z minus del Z del of del Y. This was. So this is minus IH cross minus IH cross minus minus plus, or I square is again minus the minus H cross square, minus H cross square. And this is Z del of del X. ये डिफरेंशियल होगा ये पूरे के ऊपर, तो दिस इज Y del of del Z minus Z del of del Y, and then ये minus X del of del Z is Y del of del Z minus Z del of del Y. Yeah. So this is again minus H cross square, and here it is Z, ZY del 2 del X del Z minus Z square del X del Y. Here it is minus XY del square del Z square, and then here it is minus minus plus, this is plus X del Z is 1 dy dz minus plus X Z del 2 del Z del Y. This one is. So this is Lx Ly. This is Lx Ly. Now consider Lx Ly minus Ly Lx is equal to minus H cross square, and then substituting the whole values that we have from the above two expressions. So this is y del of del y plus yz del of del z del x minus yx del square del z square minus z square del of del y del x plus zx del square del y del z minus zx del square del y del z minus z square del square del x del y minus xy del square del z square plus x del of del y plus zx del square del z del y. This value. So this is minus h square y. This factor is y del of del y. This minus with this minus is x del of del y. And remaining terms, that is this terms zy. So zy cancel with the zy. So all the double differentiator, this will cancel here. Zx cancel zy. So this is nothing but minus h cross minus I h cross minus I h cross. You take it common. And then y del by del y minus x del of del y. So this is minus I h cross Lz. This is the expression of Lz. So what we find, we have Lx Ly minus Ly Lx is equal to minus I h cross Lz, minus I s cross Lz. Or we can say this is Lx Ly cap is nothing but it is I h cross Lz. This is I h cross Lz. We have this plus because this minus is I square. So this is minus I square Lz. So in this way, we can write Ly Lz is equal to I h cross Lx and Lz Lx is equal to I h cross Ly. So the above commutation rules can be combined symbolically as L cross L is equal to I L cross. This is. Hence, the two different components of the angular momentum do not commute. So it is not be possible because product of uncertainties of two quantities is proportional to the mean value of their commutator. And this is about your angular momentum case. Now we consider the spin. We consider the spin of the electron, and we have the spin as, suppose this is nucleus and here it is the distance r, and this is electron with mass m having the velocity v, linear momentum p, and make the angular vector this. Now this electron spins. Electron spin is an inherent properties of atomic particles, and therefore it will help to understand the behavior of the particles. Like momentum, the angular momentum Lx, the spin vector can also be expressed as Sx Sy. Sx Sy is equal to I H cross Sz. Sz Sx is I H cross Sy, Sy Sz is I H cross Sx, and its value and its values are plus minus 1 by 2. Then the operator should be satisfied as Sx square Sy square Sz square is equal to H square by 4. Where Sx is nothing but Ax, Bx, Bx star, Cx. Sy is Ay, By, By star, Cy. And Sz is H cross by 2, 0, 0 minus H cross by 2. That is Z. It is known that operators expressed as matrices and the values are Sy Sz minus Sz into Sy. This is Ay, By, By star, Cy, Sz, H cross by 2, 0, 0 minus H cross by 2 minus Hz, H by 2, 0, 0 minus H cross by 2, Ay, By, By star, Cy. So if we write this expression with the multiplication of this, so we have Ay H cross by 2 plus By into 0 and Ay into 0 plus By minus H by 2, and here it is this multiply with this B star, By star, H by 2 plus Cy into 0, and this By star into 0 plus Cy minus H by 2. One factor. And the other factor is this H by 2 into Ay plus 0 into B star Y and H by 2 into By, this is By, plus 0 into Cy, then this is 0 ay minus h by 2 b star y. Here it is 0 into by minus h by 2 cy. So this value is ay h by 2 minus by h cross by 2 b star y h by 2 minus cy h by 2 minus ay h by 2 h by 2 by minus h by 2 b star y minus h by 2 cross cy. And this h by 2 is taken as common in all the ways. Then we have ay minus ay minus by minus by b star y plus b star y minus cy minus cy. So this is h cross by 2, 0 minus 2 by 2 by star minus 0. That is h cross 0 minus by star 0. And this is I h cross ax bx b star x cx, where ax is equal to cx is equal to 0 and I h bx minus h cross by. H cross by. So this value is that is Sx this value is, you can say, from this previous slide, that is the Sx Sy minus Sz Sy. So these product, that is here, that is Sy Sz. This is Sy Sz minus Sz Sy is nothing but it is I h cross. This is nothing but I h cross Sx. So we have this one is I h cross, that is Sy. This is Sy Sz is I h cross Sx. I h cross Sx. And and S x square is equal to S z square is equal to h cross square by 4. H cross square by 4. Then Sx is 0 h by 2. This is h by 2 0. That is h cross. You take common 0, 1 by 2 and 1 by 2 0. And then it is known as h cross by 2 0 1 1 0. That is h cross by 2 sigma x. H cross by 2 sigma x. Similarly, we have sy is equal to h cross by 2 sigma y. This is sigma x, sigma y, and sz is equal to h cross by 2 sigma z. This is. So the matrices for these new operator are, this is sigma x is 0 1 1 0, sigma y is 0 minus I 0, and sigma z is 1 0 0 minus 1. And these matrices are known as Pauli's matrices. These matrices are known as Pauli's matrices. These matrices are known as Pauli's matrices. So the spin angular momentum are expressed in the matrices form. The resultant matrices, the resultant matrix is expressed as, it is sigma square is equal to sigma x square plus sigma y square plus sigma z square. Sigma z square. And we have sigma x square is equal to sigma y square is equal to sigma z square, which is equal to 1. This is equal to 1. Therefore, this sigma square is equal to 1 plus 1 plus 1, that is 3. Or we can express sigma x square plus sigma y square plus sigma z square is equal to 3. This is the. And then there are several rules which governs the magnetic, like U plus and U minus are expressed as column matrices, and each component satisfy as S ZU sigma Z is equal to H cross by 2 U plus U minus, and SZ U plus 1 is H cross by 2 U plus 0, and SZ U minus 1 is H cross by 2 0 minus U. So this is all about the U plus 0 and U 0 minus 1 correspond to two spin projection, about the Z, which is H cross by 2 and minus H cross by 2, as it is clockwise and anti-clockwise direction, So this is all about your today discussion regarding the angular momentum and spin. और इसी को